Thanks for introduction. This is a work that was done by three of my students and in collaboration of Professor Jiang and in Northwestern Polytechnic University in China. We all know SSD has a performance advantage. It's a low latency, high throughput, and is not sensitive to access sequentiality. However, its write operation also has a problem. It's expensive and destructive. They're slow, then reads, and they have to be executed out of place, which may incur costs for remapping table, block erasure, even page migration. They will trigger expensive garbage connections, which increase the tail latency. The writes can also reduce limited SSD limited lifetime, which can be as low as a few thousand PE cycles. So the goal of this work is to reduce unnecessary writes to the SSD. And to address this goal, we identify unique opportunities, and there are also a serious challenge when we try to exploit this opportunity. Let me tell you a story. Say, in a typical use of file in SSD, we first read files from SSD through US code or OS kernel into application, and in application, we are going to do some updates. For example, add a new site in a PowerPoint file, editing some frames in a video file, or insert, delete, or overwrite some records or entries in the database file, or key value store application files. And then we write them back. So in a continuous evolution of files, each time the updates could be pretty minor, and many of these file blocks are left untouched or unupdated. So if we deploy a block level deduplication component, either in the SSD or in the OS kernel, and then we might able to avoid many of these writes to the unupdated blocks. But is this true? To answer this question, let's just take a closer look. We know that files on the SSD are managed stored block by block. They are read into memory block by block, and the dedup also identify duplicates in a block linearity. However, even we have a very small update, like a small insert, we have to shift many blocks or even all the blocks in a file, and then to accommodate these update. And then all these files, all these blocks become misaligned. And then the dedup component will consider all these blocks as new blocks, and their rewrite cannot be of these unupdated blocks cannot be avoided. To solve this problem, we basically propose this scheme called Freewrite, that is to retain alignments to maximum duplicates recognizable by dedup. The approach is to allow small unused spaces, we call bubbles, existing in a file to keep unupdated blocks aligned. Here example, say we have file loaded into memory, and we have a number of updates, and we also have many blocks unupdated. To accommodate these updates without using Freewrite, and then we have to shift these unupdated blocks, right, and make them misaligned, and then we cannot avoid rewrite by dedup component. With Freewrite, at the right place, we may just insert a small bubble, and then we keep these unupdated block aligned. And then they can be recognized by the dedup, and then their rewriting can be avoided. And this is implemented in the application level. The case study we implemented in two key value store applications. One of them is LevelDB. LevelDB is key value store in which key value items are incrementally sorted in a multi-level tree structure. Basically, we call it compaction, which are very expensive. And there are multiple levels. Lower level, level k plus 1, usually is much larger than level k, could be 10 times larger. And then adjacent levels are constantly merge sorted. And then because level k plus 1 is much larger, and then we consider updates, and then during this merge sort, we insert bubbles or fake key value items into the file, and to avoid its rewrite of unupdated blocks. In another case, that is, we try to improve performance of garbage collection in FAWN. FAWN is also a key value store that is always append the key value items and updates at the end of a log file. And periodically, the very expensive garbage collection operation is performed on a log file to remove invalidated items. So the huge log file could be almost entirely rewritten. In that case, we use Freewrite. We insert bubbles in new file to try to minimize or retain some unclaimed space to minimize the writing of unupdated data. And then here is some experimental setup. We implemented these two key value store applications, and we use DM dedupe as a block level dedupe. And then we basically use continuous issue put or write request with 4% repeated keys. And we control the overhead introduced by these bubbles. Basically, each bubble is less than ½ kilobytes, and the total space used by bubble is kept at 5% of the total file size. And we use 3 key distributions. The key can be uniform distributed. The key could be clustered with segments of continuous key range. Or we have a mix of these two kinds of key distributions. For the clustered, because the key are clustered, the continuous are located, so that basically reduce amount of maximum of increased amount of untouched or unupdated blocks, which is actually helpful to free dedupe effectiveness of Freewrite. Some experiment results. We have many experiment results. Basically, here I just give a few. This is about LevelDB. I show the throughput compared to the stock LevelDB in terms of throughput and the amount of data that has been written on the disk. Different key distributions, which you can see here is we have up to 20% improvement of throughput, corresponding to 24% reduction of written data. This improvement is moderate because we count the initial writes to the key value store. At the time when store is empty, we start to build the store. So at that time, Prewrite basically cannot help to improve the throughput. So the total improvement looks like moderate here. But in the second case that is formed, it basically specifically we count the improvement of throughput for the GC, garbage connection. The improvement is much more dramatic. You can see that here we basically have 4.5 times improvement of throughput, corresponding to almost 8 times reduction of written data. This is for the clustered key distribution. The summary. So in this work, we create deduplication opportunities to leverage readily available block level deduplication systems. We create opportunity to make the dedupe more effective. And we improve the write performance, reduce writes, which help to extend SSD's lifetime. And we also control the overhead, that basically the space and time overhead caused by the bubbles make it minimal, marginal, and then make sure that we have the benefit larger than the cost we spend here. So that's my talk. I'm ready for your questions.
So
capped at 5%.
It's capped at 5%.
So if the amount of bubble space over that, we stop. It's basically we suspend this function.
Is that a property of the implementation? Or is that a configurable
it's a parameter.
It's a parameter.
Yes.
What happens to the performance when you lower the parameter?
We have actually sensitivity study on that. It's not sensitive to the 5%, that one. You even decrease it to 3%, the result is pretty similar. But it's more sensitive to, we basically have two thresholds. The other one is each individual bubble. We also have a limit on that. That one is actually has a much larger impact on the performance. Basically, in this default setting, we use like 12.5% of the block size, which is half kilobytes as a maximum bubble size. If you reduce that, we basically have a less significant improvement. Yes.
The deduplication layer sits above the flash on the pointers, or how do you manage that? Is that persisted also to the installer?
Deduplication level, there could be even within the SSD or the driver. For example, DM-dedup we use is the Linux target device. So it's basically transparent to any up-level software or applications. So we don't need to take care about that. We basically just issue the request that they send, and we align that we automatically. Right?
You use 5 blocks for the deduplication, or the deduplication block is not?
I mean, it's just the block, right? It's file block. So as long as you make sure that the block you're going to write the same as a file block on the disk, they're going to match it, and then they could be voided. Yes.
Do you think this is applicable also in any type of storage system, not necessarily SSD based?
Could you say again? I'm sorry.
Why is this specifically for SSD? Isn't it applicable also for hard drives? Do you think?
Yes. You see, at the very beginning introduction, I mentioned that SSD has a good things that is its performance is not sensitive to access sequentiality. When you apply deduplication, you are going to scatter the data originally sequential in a file around right on the disk. SSD is less sensitive to that change, but if you use it in a hard disk, right, this could be, the sequential things could be, distributed across disk. In that case, yeah, the amount of data access could be reduced, but the access throughput latency could be increased. So there's compromise there. Yes.
When you add bubbles, at least in the LevelDB case, you cannot trim these sectors, right? You just add real keys, real values that you sort of ignore.
Yes.
So that means that if you do have more than 5% bubbles, you're getting into a situation where garbage collection will actually have to copy these bubbles. Because the SSD doesn't know there's nothing there. It thinks it's data.
Yeah, SSD
so
does.
It might be that you actually have like a trade-off between bubbles that are too big and bubbles that are too small, and the optimum is somewhere in it.
Yeah, but a bubble only exists when you store there. Next time, yes, let me say this. Bubble, we limit the size to the amount of bubbles. And also bubble basically appear like a fake key value items, right? Yes, and then next time when you do compaction, when you read it from the disk, at that time we need to consider if we keep the bubble there, or we can just squeeze it, right? There's a trade-off, yes, about the efficiency of disk access or the space overhead out there. Yes, you're right.
You can concatenate the bubbles, and then you're going to trim them.
If you concatenate the bubbles here, it's now misaligned.
Yeah.
No. On the upper levels, it's if they come break the bubble, then once the bubble is on the page,
at this point you've already, the deduplication won't work. You've consolidated everything.
Whatever you're gonna do is better than the alternative of writing the whole thing. So whatever you do is better, right? Because it will collect, the bubble will collect.
After, but until then, you still
Until
have.
then, it's better than taking the old data and writing the old data to a new place and
That's
bringing
not-
the whole thing. So if you are already
Okay.
getting.
Let's
you don't
continue
need
this
it.
clarification
It's-
of
it's
slides.
space.
Are there any other questions from the audience? I have one more question. What would it take, or is it possible to apply this, the bubble principle to general applications and not just key value stores?
Yes, and then we need some extra effort in that application. The reason is here when we insert bubble, that bubble basically appear like just a regular, right, key value, but it's fake. But we does not change the format of the file. Basically, you maintain the metadata. But if the regular file, like a PowerPoint or the other database files, and then we need extra efforts to record where the bubble is, the side bubble, extra metadata, and you need persistent. I mean, that kind of things, extra effort that we spend. Yes.
If in future drives, as far as I understood, there is at least the option, or vendors consider the option of employing in-drive compression instead of doing it on the host and on the use cores.
You say it compression or
Compression,
deduplication?
yes. So-
Compression.
Yes. So how would that, with your application, how would that relate or work with your?
I think that within the driver, if transparent compression is applied, I think these things need to be totally different. I mean, the idea will not be there, right? Because, the physical, the data alignment, these things would be kind of, you don't have idea what alignment is. Definitely you cannot retain any meaningful alignment for rewriting. That would be different.
Thank you, speaker again.
Thank you.